The half-finished cans are now ready for branding. The staff here call it decoration, a quaint term for putting the logo on. The task falls to a computer-controlled printer. It's a kind of Formula One version of the printer by your home computer.
This printer behind me is capable of printing all 6 colors at speeds as high as 2,300 cans a minute.
But the ink is wet. Unlike paper, metal doesn't provide a good drying surface, so the cans must make a quick trip to a curing oven. After a little bit of baking, the relentless conveyors whisk the cooling cans onwards once again. Next up, the necker. It's what gives the cans their distinctive shape. The top of the can is simply pushed together until the neck is narrowed by 10%. The cans then move at breakneck speed to an inspection area. This machine uses light to check for even the smallest hole. If the automated detective spots just one chink, the can is rejected in the blink of an eye.
The real challenge is to be able to produce the cans with such high quality because each one needs to be perfect.
Quality controllers also carefully check sample cans for flaws. One can is checked every 15 minutes. Because of the speed of manufacture, this is a sample rate of just 1 every 30,000 cans. The rejects face a vacuum-powered fate. They're sucked away for immediate recycling.
This can has to withstand 100 psi, or a pressure that's 3 times greater than that you'd find in the tire in your automobile. So it's really a pressure vessel.
The cans are now ready for filling. They head off to a neighboring cola plant. And of course, there's the same pressure on the factories that fill cans up as there is on the plant that makes them. The filling machine dishes out a precise amount of cola at an astonishing 100,000 cans an hour. The empty cans are placed in the conveyor and then sped round the machine. The timing has to be exact. If they are even a millimetre out of sync, then the entire operation will grind to a halt. The clock is ticking. The cans now have to be hermetically sealed before the fizzy drink goes flat. The process happens so fast, you can only see what's involved in a lab. Enter the crowning glory of the crown can, the top. Known as ends, these are placed over the newly filled can and then folded over to create a double seam. The double seam is so small, you have to project an image of it onto a monitor. But there it is. With seaming, a soft drink can is born. Back on the beach, a couple of cans of fizzy drink later, and our beach bums have quenched their thirst. A quick splash and paddle in the waves, a responsible bit of litter disposal, and off to the hotel for a well-deserved spot of lunch. 5 ordinary objects, 5 extraordinary stories. Coming up, how to change the tyre on a jumbo jet. Next, on How Do They Do It? They're fine in the air, mostly, and they're safe on the ground. But getting up and down really takes its toll on airplanes. The average airliner travels a phenomenal distance on the ground, up to 8,000 kilometers, taxiing and maneuvering, touching down and lifting off every year. All that contact with the runway puts a lot of wear on one particular aircraft component: the tyres. Changing tyres gives airlines a headache. Taking a plane out of service costs big money. Every minute counts, but safety is paramount. Service crews must complete a tyre change in under 30 minutes. So, how do they do it? Frankfurt, Germany has one of the busiest airports in the world. It's also home to one of the biggest airlines in the world, Lufthansa. It's 10 a.m. and Boeing 747 call sign Delta Alpha Bravo Victor Charlie is due for a tyre refit, and the clock is ticking. The jumbo comes into park, and the crew goes into action. The operation begins in pretty much the same way as changing a car tyre. Only everything's much bigger. And of course, a car only has 4 tyres. A jumbo jet has 30. They're arranged in groups of 8 under the wings and nose, attached to what are known in the trade as trucks. In comes a jack to lift the truck. The jack looks pretty standard, but it has one very special, brilliant design feature. Coming up next on How Do They Do It? This is the wheel of a jumbo jet being lifted off the ground, and it takes a very special kind of hydraulic jack to do this.
You have the pressure inside the tire, and you use the pressure from the tire to operate the hydraulic pump from the jack.
After jacking, the crew set about detaching the wheel. First, the mechanic unscrews a lug nut. The practiced movements of the crew make the job look routine. But there's no room for error here. Thousands of lives depend on this job. The mechanics have to know what they're looking for. The main sign that a tyre needs changing can be found here, in the grooves.
These grooves in here, so that's the wear indicator of the tire. So if the groove is not visible, we have to replace these tires.
As the tyre comes off, you can see how huge it is. A 1.5 metre radial, 0.5 metre wide.
They have to be very strong.
Aeroplane tyres are put under terrific strain. They have flown for several hours in sub-zero conditions. On touchdown, the tyres accelerate from 0 to 280 kilometers an hour in just 1/10 of a second. Surface temperature hits 260 degrees centigrade. That's more than twice the boiling point of water. So why don't the tyres explode on contact with the ground or implode during flight? The secret lies in what's inside them. Not compressed air like a regular tyre, but an inert gas, nitrogen.
So we fill these tires with nitrogen because it's dry, there's no water in it, so it cannot freeze, and it is fireproof as well.
15 minutes in. The crew's got the tyre off and is putting a new one on. Time for a spot of elbow grease. This giant torque wrench will ensure the wheel is secure. The mechanic carefully checks the tension on each bolt. It's a crucial moment. If these bolts ever worked loose, the results would be catastrophic. All clear. The crew is now on the home stretch. The tyre is inflated. The jack is lowered. The last bolt goes into place, held secure by safety wire. Then it's on to the next plane and the next wheel. Since this program began, 50,000 square meters of glass have been made, 40 kilometers of zip have been produced, 40,000 golf balls have rolled off assembly lines, as have 25,000 soft drink cans. And someone's had time to change 2 tires on a jumbo jet.